What's going on, everybody? In this video, I want to talk about how we can graph linear equations on the plane. So if you recall, I did do a video on how to graph equations on the plane, but the method that I used involved just basically plugging in numbers into the equation and seeing what kind of outputs you get, and then just plotting each ordered pair on the plane and then connecting the dots. But today, I'm going to teach you how to do an easier method for this. So I'm going to be focusing on linear equations today, and linear equations have the form of y is equal to mx plus b. And these two numbers right here, the m and the b, are going to tell us everything that we need to know in order to plot the line easily. So the m is the slope of the line that this equation produces, which you can define as the amount that the line rises per unit change. So if we hop from one x value to the other one, how much is the line going to rise and how much is it going to fall? That's what the slope tells us. And then this b that we learned is just the y-intercept. More of a reference point than anything. So headed into my first example here, I've got y is equal to negative 2x minus 7. So I know from the general equation of the line, y is equal to mx plus b, my y-intercept is going to be equal to negative 7, or the point 0, negative 7. And my slope, which I defined as rise over run, is equal to negative 2 over 1. So for every change in x, the line is going to fall minus 2 units in the y direction. So how do we represent that on the graph? So first, I'm going to draw the axis set, the x and the y axis, and I'm just going to label these and count by twos. So just bear with me for a second while I label these axes. 8, negative 8, good, negative 2, negative 4, and there we go. So the first thing that I'm going to plot is the y-intercept, since we know what that point is directly. It's the point 0, negative 7, and where that lies on the plane is right over here. And then from here, for every change in x, we're going to fall 2 in the y direction. So the easiest way to do this is to kind of work backwards. So instead of falling 2 and going over 1 in the x direction, I'm going to rise 2 and then go backwards 1 in the x direction, so that I can actually fit it onto this plane. So, and then from the next point, I'm going to do the same thing. I'm going to rise 2 and then go over negative 1. I'm going to rise 2, go over negative 1. And eventually, you're going to get these dots that are arranged in the shape of a line. And when you connect them together, it forms the line. So this is what the equation y is equal to minus 2x minus 7 looks like if you put it on the graph. And since it's a straight line, that's why we call it a linear equation. So in this next example, I've got 10x plus 2y is equal to 9. So again, I want this in the form of y is equal to mx plus b so that I can graph it easily. So I'm going to get y by itself and subtract 10x from both sides. And I have 2y is equal to negative 10x plus 9, and then finally divide by 2. So I have y is equal to negative 5x plus 9 over 2. So we have it in the form that we're looking at. We know that the slope is going to be equal to negative 5 over 1. So for every shift in x unit, we are going to fall 5 units in the y direction, and the y-intercept is the point 0, 9 over 2. So if I want to put this on the graph here, label my axes real quick. 2, 4, 6, 2, 4, negative 2, negative 4, negative 2, negative 4, negative 6. It's not going to be perfect, but just to get a general idea. So the point 0, 9 over 2 is going to end up somewhere right around here on the y-axis. And then for every shift in x, we're going to fall 5 units. So in this case, I move over and then move over 1 in the x, and then I fall 5 in the y direction. So that's going to give me a point about right here. And then I do it again. It's going to give me a point about right there. And then the line that I get from connecting the dots is the equation whenever we graph it. So this is the same as y is equal to negative 5x plus 9 over 2. What if I had something that looks like this, where y is just equal to one number? How are we going to tackle this one? So still, we have the equation y is equal to mx plus b. But notice what happens. We don't have this term right here. So the only way that that is going to work is if our slope is equal to 0. Because there's going to be other x values that we can plug in. So x can't just be 0. So the only way that this term goes away is if the slope is equal to 0. And we're just left with y is equal to b. So wherever it crosses the y-axis, the y-intercept, that's always going to be what the y value is, no matter what x value we plug in. So the way that that looks on the graph is if I had 2, 4, 6, our y-intercept is the 0.06, and then y is the y-intercept at all x values. So you represent that with a horizontal line across that y-intercept value. And this makes sense because if you have a flat line, slope is equal to rise over run. And since we're not rising, the top is going to be 0. And we can run in any direction. And this is the last example that I'm going to talk about today. And this is an important point. You're going to see something like this in your algebra course. Don't get thrown off. This is a lot like the last example where you had y is equal to one number. It's the same kind of thing. But in this case, it's just telling us that x is only one number. X can only be negative 3. And the way that you plot that on the graph is right here. So we know that x is equal to negative 3, and that's it. So that's going to be a vertical line going through the x value of negative 3, right? So basically it's saying that you can only plug in negative 3, but you're going to get all of these outputs as a result of that, which doesn't make any sense. So we call lines like this to be undefined. And here's why. So if we define slope as rise over run, well, if we only have one x value, we're not running anywhere. And we are kind of rising in any sort of direction. So if you have something like this over infinity, over 0, well, any number over 0 is undefined. So we have this huge no-no in the denominator that makes the slope undefined. And so every time you see something like x equals some number, it's just going to be a vertical line through that number. So I hope this video was helpful about how we graph certain types of linear equations. Did an example with a horizontal line and one with a vertical line, as well as a couple normal ones. And what you really need to know is how to find the slope and what the y-intercept is, and then you can easily graph the rest of the line. So I hope this video was helpful. Thank you guys for watching, and stay tuned for the next one. Take care, everybody.